so maybe you tried these on your own, maybe you didn't. These are our guided practice for assigning oxidation numbers and figuring out what's been oxidized and what's been reduced. So, what was our first step if we're trying to figure out what's been oxidized and what's been reduced?
Assign the oxidation numbers.
Assign the oxidation numbers to everything. So if we look at our equation, we've got methane and oxygen gives us carbon dioxide and water. First of all, what kind of reaction is this?
Let's see. I have my products are CO2 and H2O, so that makes it combustion.
That makes it combustion. It's important to know that because that'll help us out here in a second. All right. So what's the easiest thing to assign an oxidation number to?
Free elements.
Free elements. Do we have any free elements?
Yeah. Yes, we do have one.
So what does our oxidation number have to be if it's a free element?
It has to be 0.
0.
So I can go ahead and mark that as 0.
And again, even though it's O2, since it's just O, it's still 0. All right, what was our next thing that had an easy rule?
The metals.
Metals.
But we
don't have any metals.
Okay, we don't have any metals.
Okay, what's our next easy rule?
Hydrogen.
Hydrogen. So what does hydrogen always have to be?
Hydrogen always has to be +1.
+1.
So I can put +1 here.
Okay.
And I've got another hydrogen, so I can say +1 there.
Okay.
Okay.
So
after hydrogen.
After hydrogen, what's our next easy rule?
After hydrogen there was oxygen, right?
Oxygen. So what was my rule for oxygen?
Oxygen is always -2.
-2. It's just like it is on the periodic table.
Oh, that's handy.
Yeah.
Okay,
so oxygen is always -2 unless it's by itself, which is why that one was 0.
Okay. So I've got -2 right there, and I've got -2 right there.
Right.
Okay.
All right, and so our very last rule, if all else has failed us, what do we have to do?
All of the oxidation numbers have to cancel out to be equal to 0.
Right.
Okay.
So we've got 2 places where we've got to deal with that. We've got CH4 and CO2.
Okay.
So we've got CH4, our oxidation number from 1 hydrogen is 1. So what's our oxidation number from 4 hydrogens?
All 4 of them together is 1, 2, 3, 4.
+4.
Okay.
So if that's +4, what's our carbon have to be?
In order to make the +4 go to 0, it has to be -4.
There you go.
Okay.
All right, let's look at our other carbon.
Okay.
We've got 2 oxygens with a -2 each. So what's my total oxidation number from all my oxygen?
-4.
-4.
All right.
So what's my oxidation number have to be on my carbon to cancel that out?
That means carbon has to be +4.
All
so
right.
Then I can, okay.
So does everybody have an oxidation number now?
Carbon has that one, and then there's hydrogen and oxygen. Yes.
All right. So, is there anybody you can see that's boring, that's not doing anything?
Well, okay. Let me see. I've got.
So yeah, when in doubt, just write out all of our elements and what's happened to their oxidation numbers.
All right. So I've got carbon, hydrogen, and oxygen.
Okay.
So carbon started out as -4, so I can say -4, and then it went to, I look over here, it went to +4. Okay, so that one changed.
Okay.
That one's good.
Well, let's look at hydrogen now.
Okay, hydrogen. Hydrogen started out as 1 right here, and I look on the other side, and it's +1 right here. So
it went from +1 to +1. Okay, so let's look at oxygen.
Okay, so now I've got my oxygen, and oxygen right here was 0.
Okay.
And then I've got 2 oxygens. One right there, and one right there.
But
okay. Both of them look like they're -2.
Right, so it went to the same thing, so that's not a big deal.
Okay.
All right, so let's keep track of, so it started at
0,
and it went to
-2. Okay.
All right, so what do you notice?
Okay, so I'm looking, if I look at the carbon, it started out as 4. And
what kind of 4?
-4.
It went from -4 to
+4.
+4, so did it go?
So that's going
up.
And since
so
it went up
is
oxidized.
Up is oxidized.
Okay.
All right, and so then hydrogen went from +1 to +1.
So it actually didn't go anywhere.
It didn't do anything. Hydrogen's not involved in our redox. It's just there.
So do I need to worry? So I can't say.
So hydrogen didn't do anything. Hydrogen's just there. You can put a line through your hydrogens.
Take that hydrogen.
All right. So then our last one is oxygen, which went from
0 to -2. So that means it went down. Which means it was reduced because I reduced the charge.
Right. So my oxidation number went down. It's been reduced. So important note, put this somewhere, very, very big letters. Anytime you go to combustion reaction, because you're taking oxygen and then making CO2 and H2O, oxygen's got to be reduced and carbon's going to have to be oxidized. Any combustion reaction ever is redox. So if we're asking you, has oxidation as a redox reaction occurred and it's combustion, the answer is yes.
Yes.
Just like, okay, and on our last slide, you should have noted down at the bottom where it said, any single replacement reaction has to be redox because you're taking a single element and putting it into a compound. So it's going to go from 0 to whatever it is in the compound.
Okay.
All right, let's try another example.
Okay. All right. So we've got aluminum and oxygen, and those give me aluminum oxide.
All right, so easy thing to assign oxidation numbers to?
The free elements.
Free elements.
Okay, so aluminum is by itself. That's going to be 0. Oxygen's by itself. That's going to be 0. And I am out of free elements.
You're out of free elements. So next rule.
Next rule is assigning the metals their oxidation number based on the periodic table.
Okay.
So I have one metal. Aluminum is +3.
Okay.
Yes.
So then what element is left?
Oxygen.
Do we have a happy pretty rule about oxygen?
We do, actually. Oxygen is always -2.
Awesome. So we didn't even have to figure out if anything added up to 0.
That was nice.
All right. So now we need to make our list of elements and what's happened to them.
Okay, so I've got aluminum and oxygen. And aluminum started at 0, and it went to +3.
Okay, and then oxygen?
Also started at 0, and it went to -2. Okay.
So what do you notice? Which one's going to be easy to tell what happened?
Well, I can look at the aluminum, and the oxidation number on the aluminum went up.
Okay.
So that means the aluminum was oxidized.
Because up is oxidation. Our vowels are paired.
Oh, that's nice. And then the oxygen started at 0, and it went down to -2. So that means it went down. So it was reduced.
Awesome. All right. So regular folks, this is where we leave you. Get the practice from your teacher. Pre-AP folks, we've got one more. All right. Let's look at that.
Okay.
All right. So pre-AP folks, remember we are worrying about assigning things in polyatomic ions, and so we're going to have to deal with our polyatomic ion this time. Because if you notice, we start with a polyatomic ion on the left, and we don't have a polyatomic ion on the right.
Oh, I see that. Okay.
So we know something had to happen to our polyatomic ion. The other thing you will notice is we've got some ions that are just kind of hanging out without any partners. This is shorthand that chemists use because that is telling you that whatever used to be partnered with those ions is boring in relation to the reaction. Don't worry about it. It actually just makes your life easier because you don't have to figure out assigning those oxidation numbers. They just give them to you. All right, so let's assign all of our oxidation numbers first.
Okay, so we'll start with the free elements. So
Do we have any?
well, I mean, I've got some elements by themselves.
But what do you notice about these elements?
I noticed that they have the charges next to them.
Right, so if we've got a written charge, it doesn't count as a free element anymore. It's an ion. It's really actually part of a compound someplace. We're just leaving out the anions for technically ease. But
So if I'm assigning those numbers, then like the SN, when I do that, I would write +2.
right,
Oh, okay.
and then H is going to be +1.
And then, oh, I'm having so much trouble. Okay, so this would also be +2.
Right.
And that would be +4.
Right, so if it tells you the charge of the ion, this is why we sometimes leave out the anions here. If it tells you the charge, that's your oxidation number.
That's nice.
All right. So.
Okay, so now I can go and I can look at these. I can look at the two compounds I've got left. Potassium's a metal, and I can look at the periodic table. That tells me that potassium is +1. Now, okay.
So wait. The metal. Okay, this is one of the reasons why pre-AP. This is where I'm challenging you. The fact that metals get their oxidation number same as their charge only counts if the metal is not involved in a polyatomic ion. Because if it's in a polyatomic ion, weirder things are happening. So we will get to the weirder things in a minute.
Okay.
Let's deal with our other rules.
All right, so moving on. Next one is hydrogen. So I've got hydrogen over here on the product side, and hydrogen is always +1. And then I have oxygens, and oxygens are always -2. And I've got a -2.
Okay.
Right, you know what? I'm going to clean those up just a little bit because that's messy. -2. And let's do this one. Okay.
There we go. So what is the only thing unassigned?
So the only thing that left is the Mn, the manganese.
All right, because we've got potassium permanganate. We've got to figure out what our oxidation number is for manganese. So remember, this is where we can do our algebra. We know that potassium comes with what charge?
Potassium comes with +1.
So let's write down our +1 plus whatever manganese is. So we can just put Mn.
Oh, okay, so we can just put Mn, I gotcha.
Plus whatever all our oxygens together are. So if we've got 4 oxygens at -2 each, that gives us a
-8.
And that all that together has to equal what?
All of that all together has to equal 0.
All right. So what do we have to do?
So let's simplify. I've got -8. +1 is -7. So I've got manganese -7 equals 0.
So my manganese is what?
The manganese is going to be +7.
+7. So let's put +7 up there. Yeah.
Okay.
Our transition metals can do strange things sometimes. Do not worry about the fact you could never have something with an actual charge of +7. This is the other reason why it's important to remember charges and oxidation numbers aren't the same thing. All right. So now we've assigned all our oxidation numbers. So now we can actually decide what's been oxidized and what's been reduced.
Okay, so I'm going to clear some space a little bit. Okay.
All right.
So now we can go ahead and list them out. So I've got potassium,
which was a +1 and then disappeared. So we are going to assume that nothing interesting has happened to our potassium.
Okay.
So let's ignore our potassium for now.
Okay.
All right. So then manganese.
Manganese started out as +7.
And has become?
+2.
Okay.
I've got oxygen. And it started out as -2.
And
it ended up as -2.
So nothing exciting has happened to oxygen. So then what does that leave us?
So we've got SN that started out as +2. It ended up as +4.
All right.
So that was something.
So then we still had hydrogen, but hydrogen has done what?
Hydrogen, if I look up here, hydrogen is +1 there, and hydrogen is +1 there.
So hydrogen is also boring in this reaction.
Okay.
All right. So what we need to look at is our manganese and our tin.
All right. So if I look at manganese, I can see that it went from +7 to +2.
So up or
that
down?
means it went down.
So down is?
Down is reduction.
Right. We have reduced our oxidation number. And so then tin is going to be what?
Tin went up, and so it was oxidized.
Right. All right. So this, as you can tell, is not one of the nice, pretty groups we put things into.
That was rough.
Yeah, this is why redox is actually a much bigger label that covers a whole lot more reactions than we can do with our nice little groups that maybe are an oversimplification sometimes. So if there are times where all you can do is classify if it's redox, and this definitely is. All right, so now pre-AP, get the practice from me, try it on your own, make sure to ask questions if you get stuck.
Sally forth!